All right, we're in section 10.6, where we're going to find segment lengths in circles. So first thing you have to kind of be able to figure out or be able to understand is what kind of an intersection is given to us. Is it two chords? Um, is it two secants? Is it a tangent, a secant, stuff like that? That's what we're going to kind of look at, and we got different theorems that are going to help us out with those different problems. So if you look at this circle in the diagram, we have two chords that are being intersected. So anytime you have two chords that are being intersected, you can find the relationship between them. It says that EA, which is right here, multiplied it by EB, which is right here, which is the two line segments that are intersected from that point that gets intersected by the two chords, is going to be equal to, kind of the same relationship, EC multiplied by ED. So why is that useful, or how is that useful, is looking at this example here. So both of these examples has you're asked to try to find the value of x, but in this one here they want you to find ml and jk for the second one. So for the first one here is we're trying to find x. So x is essentially going to be, you take and you multiply this, which is x, times it by this, which is 6. So you're going to say 6x is going to be equal to 12 times it by 5. And so 6x is just 6x. 12 times by 5 is 60. So that means that x is going to be what? 60 divided by 6, which is 10. So that's how you find x for that situation. When you try to find x in this situation, it's going to be a little bit more challenging just because you have some addition attached to the variable, but the process is still the same. So it's going to be this value here, ln, which is x plus 3, times it by nm, which is x plus 1, is going to be equal to x plus 5, which is right here, times it by x. So looking at the left-hand side of this equation, I'm just going to FOIL it out. So when I FOIL it out, it's going to be x squared plus 4x plus 3 is equal to x squared plus 5x. So FOILed on the left side, distributed on the right-hand side. What makes this one nice is the x squareds get canceled out. And what I have left over, so I'm just going to subtract 4x to both sides to get the same. So now I got 3 is equal to x. Oh, perfect. So now I found that x is 3. So now I can go about and say, all right, where is ML? ML is right here. So to find ML, well, we just say, okay, x is 3, so that means that this portion right here is 6. And this portion right here is 4, so ML is going to be 6 plus 4, which is 10. And then JK, you have, looks like this is 8, and that's going to be 3, so JK is 11. So now what we have is two secants. And this one here is a little bit different, so um, pay close attention. So if you look at the formula here, you have two secants, so you got point E is on the outside, is where it starts the secant. And you can find those measurement relationships and say, okay, so one side is going to be EA, which is right here. It's the portion of the secant that is on the outside of the circle, but it hasn't touched the circle yet until it hits the endpoint A. Then it says that the next value gets multiplied by is EB. So it's going to be this entire piece here. All right. So people always think like, oh, it's going to be AB. No, it's not. It's going to be EB. So make sure that you do not only this, it's this portion here until it meets the circle, and then it's going to be multiplied by the whole length um, with respect to that endpoint. Same thing goes to the other side of the equal sign. So I got EC, which is right here, and it's going to be multiplied by ED, which is the entire length from the endpoint E all the way to that point D. So um, don't make that mistake. All right, a lot of people want to say like, oh, it's EA times it by AB. It's not equals EC times it by CD. No, it's not. It's make sure that you follow this formula setup to get your correct answer. So looking here, we have two secants. So what it's going to be is, in this case, this is my point. So looking at the top secant, so it's going to be 6 times it by, now remember, it's this whole thing. So it's going to be 6 plus 4, which is 10. It's going to be equal to 5 times it by the length of this whole thing is actually going to be x plus 5 because it's the whole thing, remember. So from here, 6 times 10 is 60. Distribute the 5, so I got 5x plus 25. Subtract 25 from both sides. I get 35, and that equals 5x. Divide everything by 5. X is 7. We're asked to find the value of x. Here we go. Over here, it's going to be 8 times it by x plus 8. Remember, it's the whole thing, which is equal to 7 times it by 6 plus 7, which is 13. So distribute over here, I got 8x plus 64 is equal to, what, 91? Subtract 64, so now I got 8x is equal to 27, divide 8, so x is going to be about 3.375. Okay? So now looking at this theorem, this is where you have a secant and then you have a tangent line and they share a common endpoint on the outside. So where that tangent line is, in this case is EA, whatever you're going to do is wherever the value is from point E to A, you're going to square it. And then it's going to be equal to, now this portion right here is very similar to the theorem up top. It's the measurement between E and C, which is on the outside of the circle before it hits the circle. And then it's going to be multiplied by, again, the entire line segment there from point E to point D. Okay, again, remember that. So looking at this particular one, we got to find, it says find RS. Well, RS is X, so we got to find X. So looking at the first one, it's going to be 14, so it's 14 squared. And then it's going to be equal to, all right, so the distance between R and S is X, so I leave it as that. It's going to be multiplied by the entire thing, which is going to be X plus 12. All right, so I go through this. Uh, 14 squared is what, 196? And then distribute that, x squared plus 12x. So what we have here is quadratic. Anytime you have a quadratic, we have to set the equation equal to 0. So it's going to be 0 equals x squared plus 12x minus 196. All right. So, you know, the hopes is that you could factor this out and be able to solve it. Unfortunately, there's no value that gives you a product of 196 and gives you a difference of 12. So that means we have to implement the quadratic formula. So the quadratic formula is, if you recall, is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a, all right? So if you don't remember what, so it's ax squared plus bx plus c. So in this case, a is 1, b is 12, c is negative 196. So if we implement that formula, we get negative 12 plus or minus the square root of, so 144 minus 4 times a, which is 1, and c, which is negative 196, and it's all divided by 2 times 1, which is 2. All right, so now I go over here. I got negative 12 plus or minus square root of. If you take care of, so if I go negative 4 times 1 times negative 196, I get positive 784. And I add that to 144, I get 928. So I got the square root of 928 inside this. So I got inside the square root. So square root of 928 is about 30.46. So move it over there. I got negative 12 plus or minus 30.46 all divided by 2. Because of the plus or minus, you get two separate expressions. Excuse me. Negative 12 plus 30.46 gives me about 18.46. Divide that by 2. I get x is going to be a positive 9.23. And the other side, negative 12 minus 30.46, I get negative 42.46. Divide that by 2, I get negative 21.23, okay? So, but here's the thing, because we're dealing with a measurement, it can't be a negative, so that one doesn't work. So the only one that's valid is the 9.23, okay? If you want to try JK on your own, you will have to implement uh, the quadratic formula, and x should be something close to 5.5. All right, the extraneous one that won't work when you implement it, it's gonna be negative 11.5, roughly. So check that out on your own, work it out. If you wanted, I'll even set it up. It's gonna be 8 squared is equal to x times it by x plus 6. All right, so we'll start out with that, and then you can go from there. Here, it says you are standing at point C, which is right there. 45 feet from the Point State Park fountain in Pittsburgh, Pennsylvania. The distance from you to the point of tangency on the fountain is 105 feet. Find the distance CA between you and your friend who is standing at point A. So they're asking you, essentially they want you to find the distance from here to here, so from A to C. So, but what we're going to do is we're going to call AB value of X. So implementing the formula or the theorem, I'm sorry, that we just had, it's going to be 105 squared is equal to, and in this case, it's going to be 45 times it by um, x plus 45, because it's the entire distance. So to find x, 105 squared is 11,025. And then this turns into 45x plus 45 times 45 is 2025. All right, subtract 2025 to both sides, we get 9,000 equals 45x. Divide 45 to both sides, that means x equals 200. So that's 200. But the question was they wanted you to find the distance of CA, so CA is going to be 200 plus the 45, so the distance between you and your friend is 245 feet. And here it says, suppose AB is a diameter of the fountain. It says use the diagram and theorem 10.16 to find the radius of the fountain. Well, we already solved AB in the original one, so we know that x was 200, which means that 2r is equal to x. So that means that 2r is going to be equal to 200, which means that the radius is 100 feet. And that is being able to find segment lengths in circles. Hope this helps.